Hello and welcome to section 4.3. Today we're going to look at right triangle trigonometry, and this is part 1 of 2 videos. Now, I think you've seen most of these in either Algebra 2 or Geometry, but I did want to reiterate what the definitions of sine, cosine, tangent, cosecant, secant, and cotangent were. Now, if you think about a right triangle, and I did a poor sketch, I know, but I did do a sketch here in the corner. We have some right triangle here, and we're going to look at some angle theta. Okay, before we look at the definitions, let's just reiterate that the side adjacent to theta, adjacent meaning next to, would be this one here, because it can't be the hypotenuse, because the hypotenuse is its own leg. And remember, the hypotenuse is the longest side of a right triangle. And then the side opposite would be the one that is across from or opposite of the angle itself. So, if theta is an acute angle of a right triangle, then our 6 trig functions are noted as sine of theta is equal to opposite over hypotenuse, and this does go with the SOHCAHTOA for those of you that like to use that. And I will even shorthand this even more by just writing O divided by H for opposite over hypotenuse. Cosine is adjacent, or A, divided by the hypotenuse, H. Tangent is equal to the opposite, or O, divided by A. And then we have all the reciprocal functions, which are right down below. The reciprocal of sine is cosecant, so we would rewrite this then as the hypotenuse divided by the adjacent side, opposite side. Secant then would be the hypotenuse divided by the adjacent side, and cotangent, which is the reciprocal of tangent, would then be the adjacent divided by the opposite side. Now, for me personally, I don't memorize the reciprocal function so much, as I just know that sine and cosecant go together, cosine and secant go together, tangent and cotangent go together. So because of that, I only memorize sine, cosine, and tangent, and then I know how to get these if I need them. So example 1 says to find the values of the 6 trig functions of theta. Well, here we are given that theta is this angle here. I'm given a 2 and a 4. So the first thing we have to do is identify what relationship this 2 and 4 has to angle theta. Well, 2 is really the opposite side, and 4 would be my hypotenuse. So now that I've got those established, I can then go ahead and find my sine, cosine, tangent, cosecant, secant, and cotangent. The only other thing I guess I do need to do first, though, is I do need to identify what my adjacent side is. And using a Pythagorean theorem, I know that 4 squared, or my hypotenuse squared, is equal to 2 squared plus my, we're just going to call this side x for right now. So I end up with 16 minus 4 equals x squared, or x squared is equal to 12, which then tells me that x is equal to 2 square roots of 3. So I'm going to need that now when I go ahead and find sine. So sine theta is equal to opposite over hypotenuse, which in this case is 2 divided by 4, or 1/2. Cosine theta is equal to the adjacent over the hypotenuse, which is equal to, on my adjacent side we said was 2 square roots of 3 divided by the hypotenuse, which is 4. So this will actually reduce down to the square root of 3 divided by 2. Tangent is the opposite over the adjacent, or 2 divided by 2 square roots of 3. And if I simplify that, my 2's are going to cancel, and I'm going to end up with 1 divided by the square root of 3. I will need to rationalize, so when I rationalize, I end up with a square root of 3 over 3. Cosecant then is just the reciprocal of sine, so if I reciprocate 1/2, I get 2 over 1, which is just 2. Secant is the reciprocal of cosine, so I have 2 divided by the square root of 3, and if I rationalize, I end up with 2 square roots of 3 divided by 3. And the reciprocal of tangent is cotangent, So I have 3 divided by the square root of 3, which gives me 3 square roots of 3 over 3, or just the square root of 3. And now I'm done. Now, for example 2, we want to find the values of the cotangent of 45 degrees, secant of 45 degrees, and cosecant of 45 degrees. And given this triangle here, which is definitely not drawn to scale, this right here is going to be a 45-degree angle. This here is a 45-degree angle. And this would be our 90 because it's the right angle. Now the nice thing about right triangles, and especially when they're 45, 45, 90s, is if I assume that this side length here is 1, and I know this side length here is 1, then I know that the length of the hypotenuse is the square root of 2. So I can use that information then to help me with the cotangent of 45 degrees. And cotangent was really equal to the adjacent side divided by the hypotenuse. So right now let's just look at this right here as being our angle of theta. So the adjacent side then is equal to 1 divided by the hypotenuse, which is the square root of 2. And if I rationalize, I end up with a square root of 2 over 2. Likewise, if I do the secant of 45 degrees, this is really equal to the hypotenuse divided by the adjacent side, which is the square root of 2 over 1, or just the square root of 2. And then I have the cosecant of 45 degrees, which is equal to the hypotenuse divided by the opposite side. And again, I'll get the square root of 2 over 1, or the square root of 2. For example 3, we're going to use the equilateral triangle that's shown to find the tangent of 60 degrees, cotangent of 60 degrees, and tangent cotangent of 30 degrees. Well, to start out with, we know that tangent is equal to opposite over adjacent. And if I look at 60 degrees, I'm looking right here. So the opposite side is the square root of 3 divided by the adjacent, which is just the square root of 3. Cotangent is the reciprocal of that, so I have 1 divided by the square root of 3, which happens to be the square root of 3 over 3. The tangent of 30 degrees then means that we're going to look at this angle up here, and I have opposite over adjacent, which is 1 divided by the adjacent side, which is the square root of 3, or the square root of 3 over 3. And cotangent then is going to be the reciprocal of that, which is 3 divided by the square root of 3, and when we rationalize, we end up with the square root of 3. Now this table here is included in your book. This is the sine, cosine, tangents of your special angles. And the special angles really are your 30, 60, and 45 degree angles. This table does include the radian measures, pi's over 6s, pi's over 4s, and pi's over 3s. And this is what you have to know for that unit circle quiz, which will be in a couple weeks. So if you have questions on how to find this, please let me know. You do have to memorize these. These are very, very important, and you will not be given any of these values on any test or quiz that we take. So please take the time to memorize them now. I do have a few tricks that I can help you with in class if you are struggling with these. Along with those values, there's 3 trig identities that are very fundamental. You must know these, and again, you have to know these. I will not give you these to you, and we will come to a section later on where there's more identities, but you have to know these identities. The rest of them I will allow you to have on a note card, or actually I give you a sheet. But your reciprocal identities, now we talked about how sine and cosecant are reciprocals of one another. So I can say that the sine of theta, which we said was opposite over hypotenuse, and when I do the reciprocal then is really the hypotenuse over the opposite side. Well, we can really rewrite that as sine theta is equal to 1 divided by the cosecant, because this is really 1 divided by the sine of theta. And if I do my division of fractions, we end up with sine theta. And that's going to hold true for cosine, tangent, cotangent, secant, cosecant. If you need help with those, I will help you, or I will go over those with you. Now, more importantly, quotient identities. Tangent is equal to opposite over opposite over adjacent. We also talked about how tangent was equal to y divided by x. Well, if you recall, sine is really your y values, cosine is really your x. So we also know then that tangent is equal to sine theta divided by cosine theta. Likewise, tangent is equal to cosine theta divided by sine theta. And then, for our last set of identities that we have to look at, we have the Pythagorean identities. And this is essentially that sine squared plus cosine squared equals 1. Kind of like your x squared plus y squared equals 1 for your unit circle. This is really the same thing. Sine squared is your y, so we have y squared plus cosine squared, which is really x. So x squared plus y squared equals 1. Sine squared plus cosine squared equals 1. Well, with that, we also have that 1 plus tan squared equals secant squared. And the reciprocal of that is true as well. 1 plus cotangent squared equals cosecant squared. Please, please, please make sure that you know these. So example 4, we're going to actually use some of these identities. And it says, let theta be an acute angle such that the cosine of theta is equal to 0.96. We want to find the values of sine and tangent. So the first thing I would do myself is I would go ahead and sketch a right triangle. And I'm going to just call this side here theta. And I know that cosine theta is equal to 0.96. So, if I write this as cosine theta is equal to 0.96, I know that the cosine of theta is really equal to the adjacent over the hypotenuse. So if I go and rewrite 0.96 as a fraction, I really have 0.96 divided by 1. So I know then that my hypotenuse is 1 and my adjacent side is 0.96. And because this is a right triangle, I can use the right triangle to come up with this side length here. And I'm going to use my 1 squared is equal to, and I'm just going to call that x squared. So we'll say x squared. I'm sorry, just x. That's side length x. So we have x squared plus 0.96 squared. And if I solve for x squared, this is really 1 minus 0.96 squared. So when I subtract that and then take the square root, I end up with x being equal to 0.28. I can also use my trig identities to help me with that if I didn't want to take that route. Now I have an identity that says the sine squared of theta plus the cosine squared of theta equals 1. Well, I have the sine squared of theta. I don't know what that is, but I do know that the cosine is 0.96, and that's squared. That will equal 1. So now I can solve for sine squared theta, and that's going to equal 1 minus 0.96 squared. So when I do this, I end up with the sine squared of theta, and that gave me something approximately equal to 0.0784. So if I take the square root of both sides, I end up with sine theta equals 0.28. So I just fulfilled one of my values. And I found that really with my triangle because I know that sine is opposite over hypotenuse, and we said that x was equal to 0.28. So 0.28 divided by 1 will still give me 0.28. So now that I know sine and cosine, I can go ahead and find tangent. So tan theta is going to equal sine theta, which is 0.28, divided by the cosine, which was 0.96. And this is going to give me 0.292. So I just used my Pythagorean identity to solve for sine and tangent. Example 5 says, let beta be an acute angle such that the tangent of beta is equal to 4. So we also want to find the values of the cotangent of beta and the secant of beta. So again, I'm going to sketch what I know. I'm going to sketch a right triangle. I know that tangent of beta is equal to 4, and that's really 4 over 1, and tangent is equal to the opposite over the adjacent. So if this here is theta, let's say, my opposite side is 4, my adjacent side is 1. Using the Pythagorean identity, actually let's not go that route. Let's use our trig identities right now. We know from our trig identities that cotangent of beta is 4, which means that, tan beta equals 4, which means that cotangent of beta has to equal the reciprocal of 4, or 1/4. So I was able to solve for cotangent pretty easily. Now to find secant, I'm going to use the fact that secant squared of beta is going to be equal to 1 plus the tangent squared of beta. And if I plug in what I know, I really have 1 plus, and tan beta was 4, and this is squared. So this is secant squared beta. So secant squared beta is equal to 17. In order to get secant beta by itself, I'm going to square root both sides. So the secant of beta then is equal to the square root of 17. And you would have gotten the same thing had you done the Pythagorean theorem. 1 squared plus 4 squared equals 17. So that unknown side length would have been the square root of 17 as well. So it double checks. Now, one thing I cannot iterate enough to you guys is that when you use your calculator, you have to be sure that you are in the correct mode. If you don't remember how to check your mode, ask me in class. But for all of your problems, unless they specify otherwise, you must be in radian mode. And I think on your calculator it says RAD for radian mode. If it says something like DEG or POL, that means that you're in polar or degree mode. You need to be in radian mode. Otherwise, your numbers will come out very, very different. So with that being said, we're going to do our last example here, and that says use a calculator to evaluate the cosecant of 34 degrees, 30 minutes, and 36 seconds. Well, to evaluate this, the first thing you're going to have to do is you are going to have to put this in a decimal format. And it is in degrees, so we need to put our calculator in degree mode. But to get rid of the 34 part is easy. This is going to be 34 point something. To come up with this something, we're going to take 30, and that's 30 minutes. So we're going to divide that by seconds, and then we're going to add it to the 36, and that's seconds. So we're going to divide that by 3,600. And when we get this will give us a decimal of 0.51. So my degrees then is going to be 34.51 degrees. And I'm really going to take the cosecant of that. Now when we do the cosecant, in my calculator, I'm going to type that in as 1 divided by the sine of 34.51 degrees, must be in degree mode, and when we do that, you should get 1.765. And this concludes our last example, but it is time for our college fun facts. And today's college fun facts I found on the HuffingtonPost.com website, and it was actually facts and myths. A myth was that you wait until you get accepted to visit. Now, that's not true. You want to be able to base your decision on whether or not a college is a good fit for you, and the only way you're going to know that is if, one, you go there. Well, first of all, they have to offer the programs you want. Two, you need to go there and kind of get a feel for the college life there, because most likely you're going to be spending the next at least 4 years there. So you need to actually go and visit before you get accepted. The next thing is be modest when you're writing your resume. This is one of the biggest myths. This is almost your piece of paper that you're going to use to sell yourself to those admissions representatives. They're going to have to sit there and they're going to be reading several of these. So you need to put stuff in there that's going to make you stand out above all of the other applicants. So it's kind of like a brag fest. So make sure you're including all of the things that you've done. And then a third myth was by the time you get to the application, the hard work is done. That is so not true. When you are writing your application, you oftentimes have to write an essay. Your essays, your community service, everything that you have done, you have to summarize in those little paragraphs or short essays that they're requiring you to write. You are setting a first impression to your readers. So please make sure that you are spending the time that is necessary to create a good essay or a good application. The other thing is your grades are oftentimes viewed beyond or during your senior year. So don't just think that because you've applied to college, you've been accepted, now it's your senior year, you can slough off. That is so not the case. Colleges will oftentimes go back and look to make sure that you are staying on track during your senior year. If you have any questions on this stuff, please do not hesitate to either ask myself, Mrs. Hempton, or any other of your staff members, and I'm sure they'll be more than happy to help you. So on that note, have a good night, and we will see you in class tomorrow.